about BCD subtraction. So in BCD subtractor, everyone knows that if you want to do BCD subtraction, A plus a minus B, okay. So what we are doing, this minus B, we are doing 9's complement. So let us consider first we will be doing using 9's complement. So if you are doing using 9's complement, given a number B, given a number B, let us suppose given a number B, let us suppose 3. So what will be 3? So what will be the 9's complement for 3 ma? What will be the 9's complement for 3? 3 minus B. In this case, A equals to 5, let us suppose, and B equals to 3. Okay. So what I have to do, this negative number, I need to do 9's complement for that. So how to do 9's complement ma? Fast. How to do 9's complement?
Digit minus
99
number.
minus 99 minus the number.
Yes. So it will be based on whether it is 99 or 9 or 999. That will be based on the digit that we are giving. So if I am giving 64, then you will be subtracting with
99.
99 minus 64. Okay. In the same way, if I am giving only a single digit 3, and if you want to represent this 3 9's complement, you will be subtracting 9 minus 3. What will be the result, ma'am?
6.
6 will be the result. Okay. That depends upon the 9 or 99 or 999, or that depends upon the digit that we have given in the question paper, right? B. So in this case, B, it is a single digit. So you need to subtract with only single digit 9. So 9 minus 3. Okay. So BCD means, as everyone knows, this is not the first class that we are dealing about BCD. The BCD range will be from 0 to 9. Okay. So we need to start from what? We need to start from 0. We need to 1, 2, 3. Okay. And we need to represent the BCD number for 3, 0. So if it is BCD number for 0 is what? For 9's complement, ma, for this negative, we are considering negative numbers from 0
9.
to 9. It is 9. Next for 1, it is 8.
8.
For 2, it is
7.
7. Next for 3, it is 6. Like that, you need to represent. Okay. So let me start with the explanation, ma. So let me start giving a decimal number. Giving a decimal number. Try to concentrate. Giving a decimal number and given a BCD, and you need to represent that in 9's complement form. Okay. So this is your 9's complement form. So until 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, until 9. Okay. So the representation for BCD, as we know that it is 8421, 8421. So 0 is represented as 0, 0, and 0 minus 9, you will be getting 9. So 9 is what, 9? How to represent 9? 1, 0, 1. So next 1, 1 is represented in BCD as 0, 0, 1, 2 as 0, 0, 1, 0, 3 as 0, 0, 1, 1, 4 as 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, triple 1, 1, 0, 0, 0, 1, 0, 0, 1. Now, representation of 1 in 9's complement will be what? Representation of 1 in 9's complement is what?
8.
8. So 1, 0, 0, 0. Representation of 2 in 9's complement. 2 minus 9,
7.
7.
0. Triple 1.
0, triple 1. Next, 3 in 1's complement. In 9's complement. 3 in
6.
1's complement. 6. 6 is
0. Double 1. 0.
0, double 1, 0. Next, 4 minus 9.
5.
0
Zero
1
one
0.
zero one.
1.
0 1 0 1. Next, for this, 5 minus 9, 4.
4
0 1
1
Double zero.
0 0. Next,
double 0 double 1
double 0 double 1. Next,
double 0 1 0
next,
triple 0 1
next.
0
9
double
minus 9, all zeros. Okay. So this is your nines complement representation. This is your nines complement representation. Try to concentrate much. If you know one, the remaining you can do very easily. So this is a concept which is same the one which is here. This one. Okay. So concentrate only this part. Concentrate only this part. Okay. Just now we have done the same thing on representation 0 1. I'm writing a side decimal 2 3 4 5 6 7 8 9. Okay, so same for the last class we have studied about binary addition subtraction. Everyone remember binary addition subtraction? So for binary addition subtraction, when the circuit will be acting as addition, when the circuit will be acting as subtraction. Now, can anyone? For the last class we studied about binary addition and subtraction. So in which case the circuit will be acted as a addition, and in which case the circuit acted as subtraction based on
Carry out man.
one control logic switch that we have used called, which is
Ma'am, for addition 0,
yes, good.
subtraction 1.
So there will be one input that we are passing. Based on that input will decide, there it is a switch. That switch will decide whether the circuit will be acting as addition or the circuit is acting as subtraction. If that switch, if you are passing 0, then it will be acting as what? Addition. If you are passing that to 1, then it will be acting as a subtraction that we discussed. Okay. So in the same way, I want to implement BCD subtraction as well as BCD addition in the same circuit. Okay. So for that, what I am doing is, we already discussed BCD addition for the last class. Now I need to discuss about BCD subtraction. To do that, you must know, in order to do BCD subtraction, the negative number that you want to represent must be represented in nines complement, and the resultant nines complement and A, both you need to add. Both you need to add. For that, first of all, you must know that, let us consider the same example. The same example, what is this? I will show it an example. So let us consider A plus minus B. Okay. So here, let us consider if I want to go for subtraction. I already said that the same circuit will be acting as a subtraction and the same circuit will be acting as addition. Concentrate. So if this is subtraction, I want to do BCD subtraction, then what I have to do? I have to, this minus b, I have to convert that to nines complement. For that, you must know first what is b. So in the question paper, it will be given as a equals to 6 and b equals to 4, and find out the do BCD subtraction using nines complement. Why it is mentioned using nines complement? The other complement is what?
Tenth complement.
Yes, tens complement. So it will specify in the question that using nines complement. So if it is using nines complement, what you will do? You will select 6 as it is. You will not do any modification. And this B you will be selecting, and you will convert that to BCD as it is BCD subtraction. So you will be converting that 4 to 0 1 0 0. Then what you will do? You will do nines complement for that. So nines complement is what? So 9 minus 4 you will be doing, so that you will be getting 5. So, so what you will do? Half nines complement of B is what? Nines complement of B is B equals to 0 1 0 1 0 1 0 1. Then you will perform what? For 6 0 1 1 0, and the nines complement of B, what you will perform? Subtraction or addition?
Addition.
You will be performing addition. You will be performing addition. So you will be getting a 1, 1, 0, 1, 1. Okay. So what do you have to get actually? What do you have to get actually? 6 minus 2. What do you have to get? 6 minus 4. What do you have to get? What the result you have to get, ma?
Q, ma'am. Q, ma'am.
But what we got? What this number? 8, 4, 2, 1. What's this number?
11, ma'am. 11, ma'am.
11 minus 9. What we will be getting?
2.
2. Are you getting? Yes. So we already studied that if there is a most significant bit high, the result generated is in nines complement form. Again, you need to do back so that you will be getting actual result. You leave about that concept actually. So try to concentrate here. So whenever there is what the concept that you are doing is a as it is the input that you are passing, you are giving. So try to concentrate. I am designing a circuit. My main intention is to design a circuit so that that circuit must act as BCD subtraction. So this is your circuit. Okay. So this is your 4-bit BCD adder that we discussed last class. Okay. So this is your BCD adder. So for this, I have to give one input directly. Will you accept? Yes. One input A. Are we doing any changes for this? No, we are giving directly. So I'm writing this as it is A. Okay. Then what about this? This is, if it is subtraction, then it has to be converted to nines complement. It has to be converted to nines complement. So what I'm doing is concentrate. So what I'm doing is I'm applying that to nines complement circuit. So there is a circuit and that is nines complement circuit. For this nines complement circuit, what I have to pass 4 bits? A or B?
B, ma'am.
B.
B. So we have to pass this to B. Okay. And the output from this will be, and the output from this will be, can anyone? Output from this will be, what if for example B, if I given 4, the output from this will be what? Nines complement of B is what?
5.
5.
5,
5.
ma'am.
So the output that you will be getting from this is 5. Okay. So think about what we are doing based on that. This is BCD addition. So BCD adder that we already discussed. For this, the other operand you need to give the nines complement. So for this, you have to give 4 inputs in this B value. The output generated is 5. Why? Because 9 minus 5 you will be getting 5, this output 5, and this 2, normally you are doing addition, BCD addition, and again in BCD addition, if it is greater than 6, again you have to do all those. Okay, all those will be inside this circuit. Okay, we already discussed this. It will be one 4-bit binary adder, another 4-bit binary adder. From this you will be getting Z, and from this you will be taking 6 value. All those I placed inside this circuit. Try to concentrate. Okay, but if it is given for maximum marks, you need to show what is the logic diagram in this also. Means what is BCD adder mark? So you will be having 4-bit binary adder in this place, and in this place also you have considered 4 4 4 4, and you got what Z values, and this Z values, and you created a and gates based on your expression, and if the output is high, that indicates that the what, that indicates that the output generated between two adders is greater than
9.
Yes,
9, ma'am.
yes, greater than 9. If it is greater than 9, the result generated, if it is greater than 9, we need to add 6. All that I am not explaining. Simply, this entire, simply I am placing as what? 4-bit BCD adder. So, inside that, what we discussed for the last class will be present in this. Okay. So, now we need to discuss about nines complement. So, what will be happening in a nines complement? We need to discuss. Means you must know how, given a B value 4, how it is converted to 5. We need to generate a circuit for this, and we already generated the circuit for this, and now I am giving a control switch called M. Okay, so this switch will decide. Can anyone tell me, if I am giving 4 and if this 4 is coming outside, will it be acting as adder or subtractor? If you are giving B as 4 and the output from 9's complement you are getting 4, will it be acting as adder or subtractor?
5 will be the output, no, ma'am.
Yes.
Subtractor, ma'am.
So based on this, this will decide whether, I will say, this will decide if it is 0, whatever the input that we are passing will be getting same. Means if I am giving B equals to 4, you will be getting 4. I will explain why I will explain. But see here, M will decide whether the circuit will be acting as adder or subtractor. If M equals to 0, simply for sake of understanding, if it is 0, whatever the B value that I am giving, the same B value will be getting output. Okay, means 0 1 0 0. If you are giving, the output will be also 0 1 0 0. Means, are we doing the second operand 9's complement? No. If you're not doing 9's complement, will it be acting as adder or subtractor?
Adder.
Adder. So now let us consider M equals to 1. Where is it? Now let us suppose it is equals to 1. So if this is equals to 1, what this 9's complement is doing is, this 9's complement 4, it is converting to 9 minus 4. 9 minus 4, so you will be getting output as 5. Means instead of this 4, you will be getting output as 0 1 0 1. So in this case, the circuit is acting as subtractor or adder?
Subtractor.
Subtractor. So that will be decided by the switch. But that will be decided by the switch. Now we will discuss about what happens in this 9's complement. This is the overall structure. Now we will discuss about what happens in the 9's complement. Okay. So this is your 9's complement. Now. So here, this is the input. The second operand, the negative value will be given to 9's complement generator, and you will be getting 4 output, which is, if we are giving 5, you will be getting 5 minus 9, 4 as output. Or you will be getting the same value 5, that depends upon the value M. If it is 0, you will be getting the same value. If it is 1, you will be getting the 9's complement of that B. Okay. So see here, try to concentrate. I will ask you the questions. See here, I already mentioned here, M will decide whether you are doing addition or subtraction. So if M equals to 0, what I said, ma'am? If M equals to 0, I said, if you are giving this as 5, you will be getting 5. Okay. If you are giving here 6, you will be getting 6. Means the same operand, it is getting output from 9's complement generator. So here, B value, we are concentrating on B only. Why? Because A, as it is we are giving, B only we need to concentrate. So B, what is B here? 0 0 0 0. And if M equals to 0, will you get B value or will you get 9's complement of B? If M equals to 0, will you get B value or 9's complement of B?
B value.
B value means, if I am giving B as 0 0 0 0, if M equals to 0, that means you will be getting 0 0 0 0 only. In the same way, if I am giving input for B as 0 0 0 1, you will be getting, if M equals to 0, you will be getting output as 0 0 0 1. In the same input what you are passing, after getting the output from 9's complement generator, you will be getting the same output. In such case, that is, you can conclude that if M equals to 0, the circuit will be acting as adder. Okay. So in the same case, let me see for the other case, 0 triple 1. So if M equals to 0, what you are getting, the output of the X? 0 triple 1. So these are the outputs. Okay. So if you are giving 0 triple 1 as input, you will be getting the same output as 0 triple 1. 0 triple 1. Okay. That should not be the case. That should not be the case if M equals to 1. If M equals to 1, if I want to give the input as 0 0 1 0, what will be the output? Will you get, if M equals to 0, still 0 0 1 0? What do you have to get if
No,
M
ma'am.
equals to 1? Huh?
7, ma'am. 0
7. 7. 7 means you will be getting as 0
triple 1.
Triple one.
0 triple 1. We will check. We will see whether it is getting or not. Yes, if our main concentration is m equals to 0, this is your m. So if m equals to 1, if m equals to 1, the 9's complement generator will perform 9's complement for that operand that we apply. So if it is 0, 0, 0, 0, 0 minus 9, you will be getting 9. 9 representation is 1, 0, 0, 1. In the same way, if we are applying 1, 0, 0, 0, 1, 1 minus 9 will be getting 1, 0, 0, 0, 8. In the same way, let me take the other example. What is this one? 6. 6 minus 9 is what? 2. What? 2 or 3?
3.
6 minus 9
3.
is 3. So 3 is representation of that is 0, 1, 1. 0, 1, 1. So in that way, you try to complete first the truth table. After completing the truth table, we need to design a internal logic circuit such that it has to work as the lines complement generator. For that, we need to trace out the expressions for x3, x2, x1, x0. Now, how many variable K-map will you generate for designing lines complement generator?
Four
How
only.
many variable K-map will you go? Will be
4.
4 variable K-map. As we have B0, B1, B2, B3, you will be going for 4 variable K-map. Now, note down in your notes. Note down in your notes. Then I will ask you while creating. For x3, for x3, in which positions you need to place 1 mark? For place of 0 and for x3
And one.
output. Huh?
0 and 1.
0 and 1. For x2,
Or 2, 3, 4, 5.
2, 3, 4, 5. Next for x1,
2, 3, 6, 7.
6, 7.
2, 3, 6, 7 or 5, 7. Let me go. 6, 7.
6, 7 only, ma'am.
Okay, 6, 7. Next for x0,
0, 2, 4, 6, 8.
0, 2, 4, 6, 8. Okay, noted. Now we will construct. If you complete it, then we will go for K maps. So let me start with what outputs that we selected. X8 is x4 or x. What are the outputs? X3, x2, x1, x0. Right. So we'll start with x3. We'll start with x3 with K map with K map with four inputs. What input that we selected in the truth table, ma? Can anyone?
Ma'am, 0 and 1, ma'am.
0, 1.
Uh-huh. Inputs, ma. Inputs for truth table. So these are the inputs, right? B3, B2, B1, B0. B3, B2, B1, B0. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Okay. Inputs 0, 1. Is it 0, 1?
Yes, ma'am. 0, 1.
0, 1. 0, 1 means 0, 0, 0. I have to place 1 here and I have to place 1 here. Okay. So if I am placing 0, 1, tell me what will be the output.
B3
So
complement, B2 complement, and B1 complement. Into
B, what you will be getting?
B complement into B2 complement into B1 complement.
Yes, yes, yes. And see here, ma, before going to that, as we are in BCD, try to concentrate. Mentioning don't care is very important. How many cases we need to place don't care? If BCD is import, so see here, the range, if it is 4 bits, the range will be from until 0 to 15, but we have written only until 9. So don't care conditions are from 10 to
15, ma'am. Into
mention don't cares also, but in this expression we are not using don't cares, but the other expression we will be using. Okay, so don't cares. Is there any chance if you use this don't care, will this simplify? Will the simplification group will be increased? Will it be more simplified? No, there is no other chance. So I need to group this. So if you group this, you will be getting B3 complement, B2 complement, and from this the common is B1 complement. Everyone done until this step?
Yes, ma'am.
Others please respond. Only two or three students I want from all.
Yes.
Completed until here?
Yes, ma'am.
Okay. So let me go for note down the expression. Ma. Let me go for the other expression. So the other is for x. We
Two.
have done for
Two,
what,
ma'am.
ma?
X2. X2, ma'am.
X2. Okay. Tell me the values also. Summation m of
4, 5. 2, 3. 2, 3, 4, 5.
2, 3, 4, 5. Hmm. So again 4 variable came, ma. 4 variable came, ma, with input B3, B2, B1, B0, 0, 0, 0, 1, 1, 0. It's not 1, 0. It will be 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So in place of 2, 0, 0, 1, 0, I have to place 1. In place of 3, in place of 4, in place of 5. And don't care. And don't care. Hmm. Okay? Tell me the groupings now. Is this correct? Hmm. Groupings, I will not group. Just answer, please. Grouping, I will not group. You say. So grouping. How many groups will be getting?
Two groups.
Two.
What are those two groups?
4 and 4.
Huh?
Ma'am, these 4 and that 4.
This four.
And last two and first.
Hmm.
Yes. Up, to, and down.
Hmm. Tell me the expression. From this, which what is common from this? B2, and from this B1 complement. B1 complement plus in this, it's what is common? B2 complement, and in this B1 can also be written as, can also be written as
B1 XOR B2.
B1 XOR B2. And similarly, you do it for x1 and x0. I will see who will do. Similarly, you do it for x1 and x0. X1, no, ma, we need to do now. Is it x1? చెప్పండి అమ్మా
Yes,
x1.
ma'am. X1.
x1 వాల్యూస్ చెప్పండి.
2, 3, 6, 7.
2, 3,
2, 3, 6, 7.
7. Okay. Parallelly, everyone you try to do in your notes, ma. B3 inputs B2, B1, B0. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Okay. So in place of 2, I need to place 1. In place of 3, in place of 6, 6, 1, 0, 1, 1, 0, 1, 1, 0. This one. and in this case. Okay. So remaining we need to mention don't care. So these are all don't cares. So these are all don't care. Hmm. Now next is what? Uh,
8 group,
it's
8 bit.
yes. Tell me the expression for x1.
B1.
B1
B1.
ma'am.
B1. Huh. Last one I will not do. Just tell me the answer for x naught.
B not complement ma'am.
Yes
X
ma'am,
naught
B
is
not
what?
complement.
B1 complement.
Not
B
B
not
not complement.
complement.
B
B
not
not.
complement. Okay, B not complement. Okay. So this completes your expression. We are doing for what, ma? For to apply this all the gates in where nines complement generator. Nines complement generator. So let me start with an example. It is on. It is on. Now x3 equals to. Tell me the expressions for x3 equals to.
B3 complement. B2 complement. B1 complement.
X2 equals to
B1 XOR B2.
B1 XOR B2. X1 equals to
B1.
B1. X naught equals to B naught
B
comma.
not complement.
Okay. Now, given an input B naught, given an input B naught, B1, B2, B3. Okay. So, it has to get what? X3, X2, X1, X0. Okay. So, B naught is directly we are applying a naught. Directly we are applying a naught so that we are getting what? X. So that we are getting X naught. Okay. Next is what? You try to apply the logic, ma. You try to apply the logic. In this way, it will become a complicated for you. Like x1 equals to b1. So directly we need to write. Okay. Which is what? x1. Next is what? We need to do XOR operation between this one and x2. XOR. We are doing XOR. That is x2. Why I am representing in this way is as we have nines complement generator. In that nines complement generator, this circuit will be present. So in that nines complement generator, this circuit will be present. B3. Ah. How to get x3 output, ma? What we need to connect? One is
Complement of 3s with AND gate.
the complement of this and B2 complement and B1 complement. For this, we need to apply for all
AND
the
gate ma'am.
we need to apply and this and I need to give to output x3. Okay, x3. Okay. Now let me give one input and let me check whether it is working as nines complement or not. Okay. Let me start with 0, 0, 0, 0. So first before getting an output, first tell me if we are applying 0, 0, 0, 0, if it is nines, what we have to do 0 minus 9, we have to get what output?
9.
9.
9 ma'am.
So is it getting, are we getting or not? Let me check. So B0, so x naught is the complement. So you will be getting 1 here and the 0. And what is this input now? 1 is B for x1. Directly we need to give. So B1 equals to x1. So you will be getting 0. For x2, B1 and B2. So B1 is 0. B2 is 0. So 0, 0 means output will be For XOR,
0, ma'am, 0.
0. For this,
All three are one coming one, so it will be 1.
so this is 0. So you will be getting after not, you will be getting 1. This is 0. After not, you will be getting 1. This is 0. After not, you will be getting 1. The output of all ones, the output of AND gate will be 1. So you are getting 1. Is this circuit is working as 9's complement?
Yes, ma'am.
Yes. Okay. So you don't draw like this, no? The same pattern that we are drawing like this. The same way you try to complete that this diagram, so that given we will trace for the other one. We will trace for the other one. Select anyone, give one a number, ma, so that we will be checking whether that number is getting 9's complement or not.
0, 1, 0, 1.
So 0, 1, 0, 1. It is 5, right? So 5
Yes,
minus 9, we need to get what?
4.
We need
0,
to get
1, 0, 0.
4.
4.
0,
So
1,
let me
0,
check
0.
whether it is getting 4 or not. 1, not as 0. This is 0. So from here we need to get 1. Are we getting or not? Let me check. So 1 is 0 and the other one is 1. Yes, we are getting 1. And in this case, 1 is 1. That indicates you will be getting 0. By default, you will be getting 0 as an output. So it is 0. Yes, the circuit is working as 9's complement. Okay. So in this way, this is very important. Now, in the same question, if it is asked to construct BCD subtraction using tens complement, means instead of doing nines complement plus one, you add, so that you will be getting tens complement value. For this tens complement values, you do K-map simplification, so that that will be working as tens complement circuit. Okay. So in this, inside this, whatever that we have constructed, this will be present inside that, but I'm not showing everything. I'm simplified, but in your exam, what is there inside that logic you need to mention. So in this, what we are doing is directly we are giving b1, b2, b4, b8, and internally whatever the input that we are giving, internally this all will be passed. Based on the input, this all will be passed and it will be converted to nines complement. If it is one only, if the design is circuit, the nines complement, it is an IC which is already designed. So if it is 1, it will be working as nines complement. If it is 0, this all will be cancelled and directly the input will be given. So it will be designed in such a way. So here, if it is 0, the same input will be passing as output. If it is 1, the nines complement of that will be getting, and the other operand is A plus minus B. This one I have to do nines, we have to do nines complement. This nines complement will be passing to nines complement, BCD nines complementer, so that you will be generating nines complement and this one. And until this part, what we discussed for BCD, this is your BCD adder. This is your BCD adder. Again, in this also you will be having two 4-bit. In this also you will be having two 4-bit BCD adders. From this you will be getting Z, and from this you will be getting sum. These are the sums. Okay. So in this way we will be doing BCD subtraction. Is it clear, everyone? Or should I revise once again? I will start from starting. No? So see here. It's not compulsory that you have to represent that in a, BCD addition subtraction. If you are not applying this, see here, if you are not applying this M, then the circuit will be acting as BCD subtraction only. And if in the question, if they asked that to only represent BCD subtraction, don't apply more. Okay, this is a control switch. This switch will decide whether it will be acting as BCD adder or BCD subtractor. The only change that we are doing for making this to work as subtraction to work as adder is by keeping M. So if it is given 0, the same input will be passing. If it is given 1, the nines complement of that will be represented. Why? Because one operand, we need to do nines complement of that. The nines complement generated and A, both must be, what we are doing for both, are we doing subtraction or addition? Are we doing subtraction or addition, ma'am? After doing 9's complement for minus
We're
b,
doing
are we
addition.
doing huh?
Addition only.
Addition.
Addition only, right? We're not doing subtraction. If we already discussed while representing ones and twos complement, if you want to design a circuit for what? If you want to design a circuit for subtractor, the number of borrows are more. So to eliminate that, we went for nines and ones and twos complement in the same way. This in order to represent nines and tens complement also, we are converting the second negative operand to nines complement, and the converting nines complement and the result both we are adding so that we are getting a result. Okay, so this is your BCD subtraction. This is